Let's start with a new model, and this time I'm going to call the model plate with a hole and create a part which is basically going to be the quarter of the geometry. It's a 3D deformable part. I can make it a shell. I can also use a 2D planar deformable shell. That's what I would like to use in this case for simplicity's sake. I will make a fixed point at the center because I have a radius that I need to form with a curve. So it's always easy for me to work with a fixed point at 0, 0. Then I can go about making random edges, and I can end it with a curve where I can check different kinds of possibilities. So here is one which says I can pick a center point and I can pick two endpoints, 1 and 1. So I have the geometry which is now, or the part is created, apart from the fact, of course, that I don't have dimensions to it. So now I can say I want to add a dimension of the radius, and the radius is actually 25 and not 10. So we see this strange thing happening. Then we want to also change the dimension of the other part. So let me zoom out a little bit. And the dimensions of this length, this section is 100 instead of 42. And the dimension of this one is 75. So we see it getting better now, slightly in terms of how it should look like, but it's sort of shifted to the bottom. So we want to make certain, we have to make sure that this line is coinciding with this. So we can do coincident first entry and second entry. So it puts it in the right place. And we have our geometry is created. So now with that being done, we come back out to the part. Now what I can do is that, because my main goal to teach you is more to do with meshing than with anything else, I will go about, I'll just very quickly create the material properties without giving much explanation or changing names, etc., because it's just a matter of using certain numbers, and these things we will do again in the future. So I'm not so worried about what kind of structure I want to make out of it. Just want to use a certain thickness. Let me take 2 millimeters here because this is something I did not mention to you. And here I can do a section assignment to this section to have one property. But like I had mentioned to you before, sometimes there are certain properties that don't go with planar sections. So the fact that we used a homogeneous shell does not work with 2D planar sections at all. That means we need to create a new section. So I'm going to delete this one and make sure that this time the section that I create is actually the one I need. So because it's just a planar section, I can use a solid property and apply to it. So I can just make a solid property, apply a method to it, a certain material which is done automatically, and under section assignments I can have section 1 applied to a shell of thickness 2 millimeters. I will explain this to you later when we come to shells, but this is more important now to do the meshing. Now let's go to the meshing section. Now you see that this structure is not uniform. If there was no hole in it, then we could just make rectangular elements everywhere uniformly and it would be a perfectly uniform mesh. But in this case we can't do that, so therefore we need to make some adjustments. But in general, you can also just do an automatic meshing. I'm not going to select anything, no mesh side, no mesh C, nothing. And I can just say, I want to mesh the part and say yes. And Abaqus does some kind of meshing on its own. As you see, it's quite coarse, it's quite large elements. And the elements are such that they are overflowing across the boundary, so they're not really taking the curved shape of the whole. You also have, you see there are combinations of elements that are quite rectangular with aspect ratio 1. Towards the edges, and while it goes inside, all the aspect ratio starts changing, the element shape starts changing. They are quite stretched in these areas, and you also have a couple of triangular elements here and one here as well. So it tries to set up a mesh on its own automatically if you do not ask it to do what you want it to do. So the idea is always not to go for this automatic meshing. So we remove this mesh and to have a look at the structure. So which part is actually more important for meshing? So if we look at this plate, we see that everything else is quite okay, right? We have quite uniform sections here. We know that a load will be applied at the left edge where there's going to be a tension. And the most important result from plate with a hole is the stress concentration factor at the corners of this hole. So this is the part actually that therefore becomes most important for us to study. So I know that I want to have a mesh which is much more fine in this area than anywhere else, because this hole is going to stretch to become elliptical and I will see high stress concentrations in these regions with material nonlinearity, plasticity kicking into it. So I have to think of a way of making the elements much smaller here and as we go outwards much larger. So there are some ways of doing it. Either you can say, okay, I'm going to fix the number of elements on this edge and I'm going to fix the number of elements on the other edges and then I will just do a radial mesh. That's one way of doing it. You can also say, okay, I'll just partition it in such a way that I'm making all the fine meshes in this region, the rest is all non-fine. Yeah? So there are different ways by which you can pick up the process. There is no one way of solving the problem. There can be multiple ways and there's nothing wrong in any of the way as long as your mesh is uniform, you have the right aspect ratios and you also get results that you are actually expecting. So I'm going to show a very simple way of creating the mesh. I like the way of having radial meshes. That means I will be able to set up a mesh seed on this edge, a mesh seed on this edge, a mesh seed on this edge, this one, and also at this circular edge. What I will make sure is that here the mesh is closed, all the nodes are closely spaced, and as we go away from here, the nodes are widely spaced from each other. However, there's one simple problem. This surface has 5 edges, and 5 edges are not called isoparametric surfaces, which means that there will always be some problems by setting up a mesh. So if I have 4 edges, then I have 2 edges always opposite to each other. And if I keep the number of elements on the 2 edges the same, then I will always have a uniform distribution of elements or nodes across the entire region. So I can show you an example. When I actually meshed this, you saw that the mesh was quite non-uniform, right? So even if I say all these edges have the same number of elements, it will never work because they will try to come together here somewhere in the middle, and there will be places where you will have to introduce some triangular elements. So the best way to go forward with shell meshing is that you have to reduce the number of edges to 4 always. That should be the maximum number of edges you should find in a surface to make it best, to make it work best in form of a uniform meshing. So I need to create a partition from this point right up to the center of this arc. So to do that, I'm going to go back to the part section and I will create partition on this face. So I'm going to say I want to make a partition, and I want to make a partition by using the shortest distance between 2 points. I can use a datum plane. I can also partition using a sketch, and the sketch is the easiest one I can find, so I'll use a sketch. So what I'll do is I'll just make a certain length here. So I will say, okay, I know that I want to go to the middle of this edge. That sort of looks right, and now I have the center of the edge, and that's my partition space, and I say okay, and it makes a partition. I can use the query button to check what is the length of each of the sides, so I know that it is actually the center, and I see the distance here is 19.134 and the distance here is 19.134 along the arc, so that seems quite about okay. Now I have 2 parts which have 4 edges each, 1, 2, 3, 4. So what I'll do is I'll go about putting mesh seeds on each one. You see, I will make sure that I have certain number of elements here and here and here which are the same. So I'll pick up this edge, I'll say I also want this one and I want this one, and I will put a certain number without using any bias. I will say I want to use a number of elements, not the size of the elements, and I want to use 20 elements on each. So I will see a certain mesh seed applied on it. In the same way, I will pick opposite edges like this, and I will say I also want certain number of elements, so let me also pick like 20 here, just because I want to show you some representation. It's going to be nice fine mesh, and then I will say I want to mesh the part, and it still is not managing to make a totally uniform section. Now the reason why we can't do this is that these parts are quite long stretched out, right? They're not really uniform rectangles or anything, so it's quite large. So what you have to think about is how can I actually reduce the size so that they are more or less rectangular sections. And there are different ways of doing it. So again, I'm going to remove the mesh. Please don't get me wrong, you can also work with that mesh that was just created. It's just that it's not elegant enough and it's not good enough. So if you want to have better meshes, then you have to go for better designs like better mesh surfaces.